And we're live, part 12 of the Enderwire build series. Today, I think, unless something terribly goes wrong, we will have to first print. I think last time we basically ended up with the printer homing, which is amazing. Took us quite some time to get to this point. And I did some work between the streams. Quite a bit, actually. So let's quickly revisit where we are, what we did, and then we can finish up the last little bits. So basically, what I did, firstly, I fixed up the homing. We still had some issues homing. That was quite a thing, actually. Hey there, Custard. It was actually quite a thing, and I ended up... Let me quickly just open that. I ended up having to redo the entire homing from Clipper. Oh, well, there's an important plug missing. Let's check that in a second. But basically I had to redo the entire homing, so I overwrote the G28 command. I still believe that there's a bug in Clipper with the Core XZ motion system. Now I can't remember anymore. But, oh yeah, exactly, like when you home X, it automatically thinks Z is homed as well. And if you home Z, it messes up X, so it's a bit weird. But yeah, I managed to do it by homing each axis individually when you use G28, which technically homes all axes together. I'll show the script in a second. Then, what else did I do? Very important stuff. We now have a spool holder here on both sides. Hey there, David. Greetings from the Netherlands. Yeah, so we have the same spool holder on both sides, actually. You can just fold them in and it kind of clicks in position, which is quite nice. So the idea is just to have the spool hanging here and then you feed directly into the extruder. But that's for later. What else did I do? Oh yeah, I reworked the bones a little bit. Last time we had them going to the front, which was a bit weird because I get all the bones here. I actually fed them now from the back. You have to be a little bit careful now with the bone being pinched here, of course. So you can't use the full print height. But where I put this printer, it will basically have like the top of the shelf directly above it. There will be like this much space. So I can't use the full height anyways, and I'm never using that much build height. So at the moment I just limited the Z height, I think, to 15 centimeters, which is somewhere around this height. And this is totally fine. There's nothing like pinched here. I also added this heat shrink here to kind of like combine the two bone tubes. And also like protects it from any rubbing there, but yeah, nothing will happen. And this is the realistic max height I will use 95% of the time. Yeah, I installed the print surface. So I ordered actually two different ones. I ordered the super cheap normal Creality Ender like flexible mat. Like it's not a PI metal sheet, it's just like flexible plastic mat. But yeah, well, super cheap was €6, so I was just thought I'd go with it. It comes with a magnetic sticker. And then I saw this week that the OSEC sheets, which are like super expensive, are actually on sale. They're selling off their old stock of the V1 version. And I grabbed one for the Ender 3 for €40, which is still quite a steep price for a print sheet. But they seem to be really, really good. So yeah, I grabbed one. So this will be ending up on here, which is like a PI metal sheet, like spring steel sheet. But it has like a satin matte finish and seemingly it's excellent. Let's see how that turns out. I missed the description. What is this wonderful wizardry? You mean the printer itself or which wizardry? Nope. Let's actually put it back over. Then what else I do? What I did? I cut a hole in the bottom panel for the fan. I also designed this like little fan thing, like it's like version 1, just to cover the hole. It's just clipped in here at the moment. As soon as we pull off the protective film, we can add like a dab of super glue to put this in place. Yeah, the printer, well, all of it actually, it looks amazing. Thank you. This used to be Ender 3, and I'm currently converting it to a Switchwire, which is like a Voron model. There is links to the description. Basically, it's a GitHub project from somebody else, so I printed all the parts. And I add some sprinkles of my own. For example, I added or like designed this cable channel here in the middle, like this fan mount now, some parts on the heated bed. But yeah, it used to be an Ender, and now it's becoming more. Let's really take a look inside, because I also did some stuff there. I could have not screwed down all the screws. So I also added the small screws down here, of course. Needs to be all proper. What I noticed, there's a little bit of tension, like with the bottom panel. I think it has to do with the plastic parts here, that they're like not super 100% like straight. It doesn't matter, I think, but it might be something for the future to improve. Ironic, love it. I go read the description real quick. Do that. It's a real cool project, and if you have like an Ender 3 laying around and too much time at hand, it's a real cool project, I think. So yeah, what did I do internally? Actually, the only thing I really did is install the fan. So up here, there's not a fan in here. I added this like fan grill from the back just to protect, like now we have one cable here, but still like just to protect the fan, there's one fan, or like the fan grill here. Me being me and a wizard with electronics, I managed to destroy this fan pin on the main board while doing that fan. This is a 12 volt fan, and we of course have the 24 volt pin here. I actually hit like a small buck converter like down here. I don't. Oh, I have one. No, I don't have one. It's like this little teeny tiny buck converter. So basically, the fan gets 24 volts from this cable, and the buck converter steps it down to 12 volts. And then I wanted to use this pin to like turn the fan on and off, which horribly went wrong. So this one is blown out, which is now like always on. Which, yeah, the same fate the other mainboard had. So I have experience with that. But I now control the fan with this pin here, which actually is the X end stop technically. But we don't need it. So yeah, this basically turns now the fan on and off, which is good enough. Technically, you can also do PWM, but it doesn't like the frequency doesn't work well. Yeah, then on this side, on this second mainboard, nothing happened. David, we use two mainboards here actually. They're both SKR Mini E3. The reason is that we have two extruders. So basically, this board drives 4 stepper motors, and this one drives 1 additional extruder. So that's why it looks a bit wild, but it works well. Oh yeah, safety. I added one more thing. I added a grounding of the frame. So this just goes to the ground pin from the main board, from the PSU. So basically the frame is now grounded. I checked with a multimeter that if I put the multimeter tip on the screw and I put it on like some frame part, the entire frame is grounded. We didn't have that before, and it's kind of important, but I live in a quite old house, and these are my outlets. And you very much do not see a ground pin here, so it's nice that I have it in the printer, but this wire is not connected to anything in reality. Life sucks. I decided to do a redo all my electronics on my Ender, and I'm mostly done. Oh, cool. I remember you had quite a lot of trouble with your Ender, right? Like that wasn't quite a love story. I printed out Switchwire skirts, and I'm using 2 boards. Welcome to the club. 2 boards is the absolute minimum you should use in a printer. I actually like, while doing the fan, oh, I put it away, but I have a 3rd board of those, right? And the 3rd one is completely shot with the stepper drivers. So I actually connected 3 boards to this machine and had the 3rd board like to try out the fan. And it worked also really well. So Clipper can handle that really well, which is cool to see. I'm sending pictures in the Discord. Yeah, I'll check it later. Cool. Yeah, so that's all we did so far. So basically it is kind of ready to print. We just need to set up those, or one of those 2 stepper drivers for the extruder. And once we do that, technically it should be ready for our first print. So what I would just do now is let's plug in one. I have no clue if it's left or right. I'll leave the other one unplugged for now. So let's just plug in the extruder. I'm still nervous every time when I turn on this machine. Like my confidence in my electronics game is completely shattered. But yeah, so let's set up the stepper here, and I plugged it into the extruder motor port. So we need to see how it wires then in the Clipper config. So let's leave the bottom panel off, but I'll put on the feed so we have a stable surface. And then I guess we can dive into our Clipper config and make the extruder work. Before we start a print, we have to do a couple of like small maintenance tasks. We need to check the belt because they're definitely too loose. It will work, but let's just quickly check it. And we need to calibrate the extruder, of course, because we have a 5:1 ratio on the extruder, so that's definitely not set up properly. It's getting heavy. Every stream it's getting heavier. Okay, let me make sure that's off and plugged it in. Okay. So I'm always nervous. Let's see if we get sparks. No sparks, but I hear BLTouch clicking. And also you hear the, like you don't, but I hear the fan always turns on in the beginning. Until Clipper boots and then turns off the fan. And the fan then is activated basically as soon as the stepper drivers become active, the fan will turn on. So 2 extruders to 1 hotend. Yes, exactly. I don't know anything about Ender 3, so apologies if that's something I should know. No, it's definitely like Ender 3 is just like a super cheap printer. But we have 2 extruders. They are left and right. It's basically those parts here. I also have a little bit of filament here already in. And then basically they come together to, to this like Y part here. So basically this just is like, just like a Y. They basically come in. And what you can do is basically to change the filament during the print, like one extruder pulls out the filament far enough that it's like in this section here, and the other extruder can feed in the filament. Technically it should work. Like I'm not inventing this setup, like people did it before. But we will have some fun like calibrating this and making it like solid that we can like have multicolor prints. Normally Enders or switchers don't have 2 extruders, just was using 2 extruders so you can do multicolor. Exactly. For example, like this tool head, I want to reprint actually. Like here I basically first printed the yellow parts and then the black parts, but ideally you just do it in one print. Also I'm trying to get Clipper running on old Android instead of in Raspberry, as well as running Clipper screen. There is Octo4A, which runs on Android, right? I wonder whether you can misuse that to run Clipper. Technically it should be possible. I'm not sure if there's like any projects that do Clipper on Android. It would be really cool. I have plenty of phones. Yeah, it's up and running. It already booted. Yeah, let's dive into the config. Let's not use any time. And there's a GitHub that has Clipper on Android. Oh, cool. The only thing I know from experience is that I mean, most likely for Clipper doesn't matter so much, but the Octo4A stuff is really picky with installing plugins on Octoprint. There's some issues sometimes. But I guess for Clipper you don't really have plugins, so if it runs, it runs. Requires rooting the phone and a lot of work, but hopefully it will work. Yeah, I expected that you would need root. Okay, so we are running basically two main boards, right? One is the SKR Mini E3 V3 and one is the SKR Mini E3 V1.2. Just to recap quickly, I have them set up here. So the main MCU is the V3 one. And then we have the MCU V1, which is the second mainboard. And then the one that we temporarily used in the middle was the SKR Mini E3 V2, which I still have here. So technically you can just uncomment that, plug in the third mainboard, and it has 3 mainboards, and it works really well. But yeah, we work now with the V1. We need to figure out how to configure multiple extruders at one point. But for now, one is fine. I see we already set it up with V1, but we need to figure out if this is the correct extruder, correct stepper driver. Let's quickly poke. This is the V2 config, and this is the V1 pinout. Now we don't have to open anymore. So SKR Mini E3 V1.2 Clipper config. Yeah, and let's just quickly peek here. So they have PB3, PB4, PD2. Let's quickly compare it. What we have, PB3, PB4, PD2. So exactly, and this is like negated. The enable pin is negated. Yes, exactly. And then for the TMC stepper driver, they have PC11, and that's it. Run current 650. It's a little bit higher than what we have, I think. No, it's actually higher. PC11, yeah. I'm not really not sure about those run currents, but I will just leave it as is for now. But that means that technically we can do a stepper bus, and it should do something on one of the 2 stepper drivers. I can't wait to see this, even if it's available. It's wildly interesting. Bamboo's multi-material works, but it's kind of clunky and slow. This won't be much quicker. Like, all multi-material is just slow. That's just in general. Like, the benefit here is like you don't have to retract as much, right? Like for Bamboo, let's say like the shared filament path is really long, right? I mean, I don't have a Bamboo Lab printer, but if I recall correctly, like you have to retract the filament all the way to the multi-material unit. And here you only have to retract this far, and then you're already like in the separate path. So that might be a bit quicker, but yeah, exactly. It's very long. So here's really just like this very short step. Like technically, until here, like from the hotend, like maybe this much you need to retract. But today we will focus on single material, I think, first, and print something small. Yeah, let's just do a stepper bus. Stepper equals extruder. Perfect. That worked well. Unable to read TMC UART extruder, register IFCNT. Okay, cool. That worked well. I was thinking to multicolor printer, but instead of 2 extruder, 1 hotend, I'm going to use IDEX. Oh yeah, that's also a very cool setup. That's definitely quicker because you don't have to do all the purge blocks and stuff like that. Okay, let's figure out what's wrong here. What did we forget? What did we forget? We have PC11 as UART pin. We have PB3, PB4, and PD2. Maybe let's quickly just do a check and just home the printer once. I'll be able to do it once I get a new... Oh, there's something in the way. Hotend? Extruder and linear rail. But do you do it on your Ender 3? Because like IDEX would be like really like constrained. Like you would need to widen the frame, right? Or like which printer are you doing the IDEX on? Okay, so we are homed. So that definitely works. So I'm still a bit confused what we would miss here. Because it looks all fine. I mean, this one we need to tune later. Oh yeah, we can already tune, because we have an M4 extruder, we can already set 80-20 here, but this doesn't really matter for now. It's all like sensor and everything, that's fine. Yeah, it looks good. I don't see the problem. I don't see the problem. PB3, PB4, PD2. Let's just try again. Maybe it's just something weird. No. Yes, I have a 4mm extrusion that I will use. It should have enough space on the sides. Oh yeah, for sure. 400 should be fine. Because you need like, if you keep the print volume, you have like 23, I think this is 23.5. So you have like almost 10 centimeters each side. Yeah, it should be fine, I guess. But do you widen only this extrusion here, or do you also widen like do you widen the entire frame, or do you just extend it basically out? Oh wait, no, I didn't read the error. Was it the same? Let's quickly do it again. Let's quickly Google that. No, we were here before. That's not good. I was getting the unable to do because I hadn't connected the 24-volt power supply to the motor power terminals on the Octopus, and so stepper drivers weren't getting power. Now that's not us. Ah, but this is exactly our board. This often happens when the power is applied to the microcontroller but not to stepper motors. Make sure power is fully up, double check the wiring. I mean, yeah, because it's driving the other steppers. Between Y and X. Has two more step tier and UART mode. Customers can choose. No, there's no solution here. no config issue. That's very good. It's saying it can't read a UART. Could check the boards from the command line. Yeah, well, the board is fine, right? Like the board is also driving the other steppers. So it's homing, so the board itself is fine. It must be something with this one specific stepper. What we could do, just like for the sake of trying, let's quickly shut down the Pi, that we don't pull from power. Let's just quickly try the other stepper, because we have like two stepper ports free, right? Let's just quickly try the other one. But I'm not aware of any issues with this main board. So let's gently put this on the side. Let's actually flip it over. Okay. So we tried this one. I mean, we can leave it plugged in. Let's just plug in the other one and see if we can get this one to work. But I wonder if there's something. No, there's no jumpers or something we need to set. Let's just plug this one in. And it's also like everything's properly plugged in. It definitely has power, right? Like there's nothing else we need to do. Like this one is connected, so this is fine. This is fine. I mean, worst case, if this one is broken, we can always use this one. Those three are blown out. Don't ask how this happened. But those three are, like, it's technically only two. One has two plugs. This one we can still use. So if this one for some reason doesn't want to work, we can just put a cable here. Like this cable is coming from this side anyways, I think. I mean, one cable comes from here. Oh, you don't see it. Sorry. One cable comes from here and the other cable comes from here. So one of the two can just move up there. That's not a big deal. But then we are absolutely like out of stepper drivers. Yeah, it's plugged in. Let's flip it back over. But yeah, what happened with those stepper drivers that are broken? I'm like a little child sometimes. And by sometimes I mean 99% of the time. So I was like playing around with the tool head and moving it quite quickly. I wanted to see that the cable chains run smoothly. And I enjoyed it a bit, so I played around a bit. And I moved it seemingly so quickly that I overloaded the stepper driver from the induced power from the motors. So, success. Yeah, let's turn it back on. I'm still nervous turning it on. Seems good. As soon as I hear the BLTouch clicking, I'm happy. But yeah, we had some electronical setbacks in this build, that's for sure. So I basically blew out one stepper driver on the SKR Mini E3 V1.2. Definitely not the one that we are now using because it wasn't connected, so that would be really weird if that would be damaged. And two on the other board. So out of 8 stepper drivers I had, I damaged. Oh no, it's a lie. I swapped out this board. This board was not part of my calamity. I had a different, like I have 3 main boards. And this one I swapped in after I had the issue with the step driver. So this is completely unaffected from my stepper driver gate. Yeah, so here we are. Let's put in front of it. Let's quickly home. And then we should have now paid attention which stepper we now plugged in. I would guess it's... Let me just quickly peek. It says Y. We plugged in Y. Okay. Then let's quickly check our config. So we need to check the Y stepper and copy the values over. This is the PB10, PB2, PB11. And the deer pin most likely is not inverted for us. So the deer pin basically just reverses the direction. That's that. Okay, so I'll just comment it out for now. So it's V1 PB10. Never got the others, of course. 211. PB2. I'll leave out the exclamation mark. V1 PB11. And this needs the exclamation mark. PB11, yes. And then we have PC6 as UART pin. So I also comment out this one. V11 PC6 is a UART pin. Let's quickly double check. PB10, PB2, PB11. PB10, PB2, PB11. And then UART pin is PC6. And here we have UART pin PC6. So let's save that. Let's save that. And let's stepper bus and hope that... Okay, no. This is really weird. So we have the same issue on both stepper drivers. So there's something we miss. There's something we miss. Yes. We missed this line. The UART, so here's the difference. On the SKR Mini E3 V3, all stepper drivers are connected to one UART pin. So if we check the config here, you see that they all have the UART pin PC11. This is the V3 config. They all have PC11, and then they have a UART address from 0, 1, 2, 3. So they all have the same pin, but different addresses along the bus. So they're like a chain, basically. You see here, the Z stepper is UART address 1, and the Y stepper is UART address 2, and the X stepper is UART address 0. So here's the problem. On the V1.2, the UART address is not configured, but each of them has a different pin, PC6, PC10, PC11. So the UART address for each of them is 0 because it's like 4 chains of one stepper compared to one chain of 4 steppers. And this is why it can't read the register, because we say here UART address 1, and 1 doesn't exist. Like this chain only has one stepper. So we need to comment out this, and then let's... Yeah, it doesn't matter. Like let's keep this one. Now let's use the extruder pin as the main extruder. So I just saved it here. So let me just quickly do it like this, and then we copy this here. Okay, I'm very confident that it now works. As you can see from my very elaborate explanation. That is it. Let's delete those to prevent confusion. Nice catch. Yeah, well, I stumbled over that last stream already. I forgot now before I remembered. Okay, but now we can stepper bus. Yeah. We have a stepper bus. So this is a success. Cool. So we have a stepper motor. So I would say let's calibrate the rotation distance. I do have a bit of filament, which is conveniently gray, and I have a marker somewhere. Here. But because I always do it wrong and forget something, let's just quickly check the good old Alice tuning guide. Dum dum dum. 101 or higher. Yeah, exactly. It's once, because I already saw this was 100 for us. Max extruder only distance. Let's set it to 120. Save and restart. By the way, if somebody doesn't know this, like this is like the holy bible of printer tuning. Is really good. Like I use it a lot for my V0. I actually just went through pressure advanced tuning again there. Yeah, it's really good. Also like the troubleshooting section down here. If you have any problems, it's really good, and it's like constantly being like extended. Oh yeah, we've got the min extruder temp. It's a really great guide. Yes, we have that configured, so we need to set it to 0 now, that we have cold extrusion basically, so we can extrude without heating up the hot end. So yeah, so we just measure our 12 millimeters and then we just pull it through. So basically we measure out, I guess everyone did it at some point. So let me just put it nice and square that you see it like head on. There's a bit of filament in there. Is this long enough? No, yeah, definitely. Let's just use this one. So I'll just feed it in. So we detach basically the bottom. Or we try to detach the bottom. Then we feed in the filament. Not quite familiar yet with the extruder. Hey there, Mike Nexus. Nice setup. Thank you. New channel just out. Thank you. I'm actually like, since I started the Enderwire streams, I got so many new subscribers. Like, I don't really care because this is just for fun for me. But like at peak, I had like 180 new subscribers in 1 month. I never had that many. So, a little bit out here. So let's just, I'm measuring the wrong side, obviously. I'm just aligning that, and then let's put a small, maybe it's even smarter if I quickly grab some tape, because in our market it's yeah, let's do it. So this is, we are marked. The next one we just marked with two slashes. Random unrelated question: is anyone aware of any consistently good and dry PETG and ASA filament? I'm using bamboo, but the last batches have been very wet. Well, my experience with PETG is, even if you have like dry one out of the factory, the moment you unwrap it, it will get wet in no time. What I do is I keep I have very little PETG filament by now. I mainly use ABS and PLA. But I keep mine in vacuum bags. Basically, as soon as you're done printing them, I put them back into vacuum bags. That's the only way to keep it dry. And even then, if you have it open for a little time and it was like outside while being printing, you still need to dry it again. So filament, if you want to print PETG, in my opinion, filament dryer is essential. 3D printing folks are a great group. Yeah, I totally agree. Like, it's a really, really cool community. Finding new stream. Did you manage to get the bad probe working? Yes. The issue with the bad probe was that there's a... I can kind of show it. Let's quickly do that and then we start calibrating the extruder. So the issue was... The root cause is that the PCB for the toolhead I have is not really meant for the BLTouch. Like, there are seemingly different versions which I was not aware of. And this one is made for 24 volt probe, and my probe BLTouch is 5 volt. And the issue was, you see the little blue cable here. There's a diode here on the PCB, and that diode prevented the signal to the yellow cable. Like the signal basically coming from the main board needs to go to the yellow cable to tell the BLTouch to extend, and this diode basically interrupted that signal. I don't know why, because the diode is in this direction, so it should work. I don't know why, but I just added this little like solar bridge here with this like jumper wire, and that solved the problem. That was all that was needed. Like, the configuration was correct all the time. It was just that basically the signal didn't reach the yellow wire. Yep. So that's the side. Mine comes out of the bag into the dryer for 8 hours, then into Bamboo's AMS. It worked great a few months, but both the PETG and A now require an unsustainable amount of drying. Well, I never tried the bamboo filament. What I use, but I never tried the PETG, and it also depends a bit like where you are from, right? Like, because like you have different suppliers locally. I use the From Futura stuff by now, which is really cool because they're like a local company. They're like 20 kilometers from here or something. And I order it directly from the manufacturer, and it's here the next day. The ABS is amazing. I use the Titan X ABS. It's all the black parts. The PLA is a little bit... I'm not super happy with the PLA yet. PETG, the only one I used so far was from Filamentum, which in the beginning was great. Like, I had one purple PETG from Filamentum. That was amazing. Like, I really liked printing with that one. But then I had the second one in Vertigo Gray, I think was the color, was like sparkle color. And this one was really horrible to print, so wouldn't recommend. Yeah. Okay, let's see. So we set M83, and then we set we pull in 100 millimeters of filament. Let me quickly... Oh, there's the configuration issue. Min extruder temp must be a minimum of 10. I set it to 0. Let's set it to 10. Yeah, but for ASA, like, I mean, I use the Titan X ABS, which works really well. Like, it's a very forgiving ABS. Like, it prints, like, I even printed it open air before. Works okay. But yeah, that's my only ABS ASA experience is with this one filament. Yeah, I guess we can M83. It's doing something. Let's make sure they have a good view of that action here. But I already see like it's pulling the wrong direction. That's not what you want. It's pulling. But it is extruding, so hey, I count it as a win. Let's quickly check our config. There is an exclamation mark that wants to be set. So the direction pin, we just invert that. Oh, we just invert this direction pin here, and that's all you need. You most likely didn't offer a firmware restart because we're extruding. Seemingly we have to wait. I mean, I could emergency stop. Oh, by the way, there was an update for mainsail available and a fixed emergency stop. Last stream we had to think that when you click emergency stop, it did emergency stop, but it still showed a confirmation dialog. And that's now gone after the update. So there was indeed a bug. Okay, let's quickly just check that we now extrude in the right direction. I'll just pull 10 millimeters. Yeah. That looks much better. Yeah, then we have to redo our marking, of course, because that's now off. There's a setting for the emergency stop section confirmation. Exactly, there's a setting, but the setting was to not ask for confirmation, and it still asked for confirmation. But it also didn't wait for your confirmation to be given. The emergency stop was immediately, but it still showed the dialog on top. So it just shouldn't have shown the dialog. So like the emergency stop happened, it's just like the dialog also was shown. So there was definitely something wrong. Okay, then let's pull 100 millimeters. Yeah, I did a fatal mistake today, and also my V0 updated all the clipper stuff, like everything that was there to update, I updated, and immediately stuff broke, of course. The webcam wasn't available anymore. So I had to completely uninstall Crow's Nest and reinstall Crow's Nest, and luckily it worked again. But I never learned the lesson that you should just not update your clipper once everything works. Also on this machine, I updated, like there's a section here, System OS packages, which I will never touch again in my life. I did it on the V0, I updated the System OS packages section here, and then it didn't find the clipper boards anymore. The MCUs were just gone. And seemingly the latest Bullseye Linux images have a faulty serial driver or something that causes problems with Clipper. And then you have to like downgrade that again. But now there's an automatic script that does that, which is very handy. But for the V0, it took me like half an hour, like changing packages or package registries and everything. And I'm not a Linux expert, so stuff like that always takes me a second. But yeah, this is now, unless there's like a magic new Clipper feature I really want, I'm not going to touch it anymore. We're almost there. All right, I also give you a bit more depth of field. Okay, so it's up here. The marking is right at my finger, so it's not terribly off. So we are at 23 millimeters. 23 millimeters out of 20. Scary as fuck updating anything once everything works. Yeah, but I can never resist the urge. My Clipper on the Ubuntu laptop, I never touched the updates. Yeah, that's a wise decision. I mean, like, it's not a thing that's on the internet. So, yeah, security is kind of like second, in my opinion. That's just my uneducated opinion. Like, it's not in the internet, it's not public, it's just in my home network. So, the risk on not updating stuff is really low. 23 millimeters. And one thing I'm even worse at than electronics is maths. So 120 minus 23 is 97 millimeter actual extrusion. And then the new rotation distance is the previous rotation distance. So this is times actual extrude distance, which is 97 divided by 100. Okay, now let's check the actual extrude distance. What do we have here at the moment? And then we just need to redo that again. I think that's wait, is it rotation distance? Yeah, rotation distance, right? Yeah, rotation distance. I said extrude distance the entire time. This is a very precise number. I don't think it needs to be that precise. This one's a comma, so it's 21. Let me just copy that entire shebang. This is our new very precise number. Let's just quickly do it again. Still have enough filament to just set a new mark on the bottom. I always struggle to hold this, like pull the filament. Because I kind of want the filament to be like in a straight path. Okay. Filament is marked. I'm quickly sending M83 and then I'm sending G1 E100 F60. And we wait again. But I'm really happy that it works. Now it's just extruder turning, but there are also like really nice marks. I'm not sure if we can get this close. Yes, I can get this close. I'm very impressed. I mean, they're really nice like grab marks. I think this is like close to perfect. Like it's definitely like grabbing onto that. Really nice. This is such a cheap ass lens. I got the second hands for 70 euros, this lens, but it's really perfect. Like it's a super crappy lens, don't get me wrong, but like for this live stream stuff, it's really perfect. There should be a printed part for this. Yes, that's also what I thought. Like just like something you can dock and then like click the filament in on the bottom and then make the mark. I mean, I could design something, but then like, it works. It's not perfect, but it works. I'm really like interested to see like how the stepper driver performs, because this one is the if somebody watched the entire series, like at some point we swapped the steppers. So the Ender comes with two different stepper sizes. Those are still the steppers from the Ender. This is the small size, and then there was like the larger size. And the only larger size stepper on the Ender was the extruder. So I wonder whether the extruder really needs that much power, because now we have them on the AB motors for the Z and X basically. We are done. Let's see. Now we are at 18. So that was 18. Yeah, it's called 18. So that was a bit too much. So we are closer. Wait, did I do it wrong? Actual extrusion distance. It's 120 minus 18. Yeah, 102. Yeah, I did it correct. So we have 102, and now we have our new number here. It most likely will take us a couple of iterations until we are like at a good value. We don't have to overdo it, I think, for now. But I still want to get it somewhat close. And now we are back at 22 too... Maybe I mismeasured. That's always like a possibility that you like don't measure correctly or don't mark correctly. Let's see. Technically, we could also take a look at the belts, why this is doing that. Oh, I forgot to set a mark, right? Let's quickly. Emergency stop. Let me put a mark. Let me put a mark. M83. Now we have action. Yeah, so the belts are a bit loose, like especially here on the long side, they're quite loose. But then like on the top, they're also a bit loose. But I'm not quite sure how tight they should be. That's a bit my thing. Because like you have really short sections. Like for example, down here you have like short section. This is like quite tight already. But I think we should definitely tighten it a little bit more. Let's see. Let's quickly try to calibrate this extruder somewhat. And then we take a look at the belts. And then I think we're ready to print. That's really like the only thing. What we can do, like while this is doing a thing, we can go to printables. Any suggestions for first print? By the way, I ordered my, or like I didn't order, but I broke the 350 Prusa meters this week. So I exchanged my 350 Prusa meters for a spool of PETG Prusament. So I can give feedback on that in a couple of weeks when I get that. Seemingly it takes 2 weeks for the voucher to process. Maybe we have some Halloween models. Oh, wait. Contest page. Let's see. There's an app for belt tuning. Might be too much. No, the app is perfect. Actually, Prusa has it now online, which is really cool. Like Prusa belt, if you Google that. Because you had to use this like weird as guitar tuner stuff. But yeah, you can now like just use it. Like it only suggests Prusa printers, of course, but it doesn't really matter. You just have to enable a microphone access. You don't see that. There's pop-up up here. And then you just have it here. The problem is that you need to know the hertz of the belt, and that depends on the length of the belt run. So the shorter the belt is, the higher the hertz number will be. So I'll just do it by feeling. The important part for us is that both belts have the exact same tension. Because otherwise they're not printing square. This is bang on. Oop. That's a bit dark. I'm sorry for that. All the light comes from the top. This is like perfect 20 millimeters. I'm sure you can see that. So I would consider this tuned. Get this out. Yeah, I have to light a bit more that direction today. So everything here is a bit dark. Maybe I should pull it back a notch that we have more light here. Let's see, if we keep working on stuff here, maybe I just quickly move the light. Okay, then let's check out the belts. So, probably some nasty math involved. Yeah, lots of that. I can tell you it's not my favorite. Okay, so yeah, it's quite loose. We have the tensioning mechanism here. So I would just grab one of the belts and let's just tighten that it's like comfortable. Let's just move it up. I mean, this length here never changes because this goes always from from the top to the bottom here. So let's just aim to make this one somewhat tight. I would say that's the longest belt run. Let's see, does it work? Oh yeah, it's tightening. I think this is already somewhat okay. I want to over tighten it. I think this feels good. Oh yeah, the interesting part is, so because this is a Core XZ system, right? So basically, if I pull on this belt here, this driver, it moves diagonally up. And if I pull this one, it moves diagonally this way. So the important part for us is that both belts have the exact same tension. Because if not, I mean, right now they definitely do not have the same tension. And I can show you what happens then. So if I now move this up, you can see now that this side touches. Like this is like top. But this side now has a gap. It's not actually as bad as I thought it would be, but there's a gap. So basically, because the belt tension is unequal, we are pulling the x-axis out of like level. So this is one thing where we, like how we can check that the belt tension later is exactly the same. But it's interesting, like both belts tensioned. It's definitely also like, this side also feels tighter. Hi there, Joe. Let's see. Oh yeah. I wonder why. Like, this one here is now completely loose. That was definitely not the case. So there must be some other magic going on that I'm not aware of. So basically this hooks into the extrusion here, this part, and pulls the motor down basically, and by that tightening that belt. Okay, so let's see. So now we need to figure out which belt we need to tighten. Yeah. Oh yeah, now I see. What I'm doing now is basically I'm pulling this belt like this. This is the movement I do. Now watch this top part here. There you have your gap. And I'm pulling now this part. And you see like how this moves up the x-axis on this one side. Like if you look at the other side, this stays the same. But this side basically moves up. So we need to make sure the tension is the same, that like both sides of the x-axis are equal. Otherwise our prints will be skewed, which we don't want. So I'm now just moving that up, and then we can like tighten that and observe how we pull this up. Yeah, now it's too tight because now we have a gap here. So let's loosen it again. Now it seems good. I'm moving it very slowly since I burned out the stepper by moving that. But this looks good. Yeah, here it's now really tight. So I'm not sure if it's now too tight, to be honest. Like this is all fine, but this section here is now... But I guess it's just how it is, right? The shorter the distance, the higher the frequency. But I think the tension itself isn't much more. Okay, let's home that quickly and see what happens. Hi there, Alex. Pretty smart X leveling system. Well, it's for the Core XY you have the same, right? You have to make sure the belt tension is the same because otherwise your prints are like not like square but like skewed to one side basically. So that it's parallel but then skewed. So here it's the same. It's just like flipped up basically. Cool. So we are technically. Alex, you just came in time for the first print. I think we are completely ready. I don't think there's anything else we need to do, right? Like we calibrate the extruder. I did the pit auto tune actually during the week, so that's also done. I didn't want to do it on stream because it's always like you have to wait for so long. It's not really interesting to like watch the temperature graph rise. So I guess try to feed it some filament. If I manage to get the filament in. I think one of the things I need to learn again. What's the best tactic to feed filament through that extruder? Here we go. I'm just manually pushing it now. Oh, it's also the first time we actually try out the Y section here. So I'm very curious to see how that goes. I mean, now I'm at the end. Oh, see now here there's a hitch. Now I'm at the hot end. Okay. I guess we still need to select the model, right? There's no model. Nice speed benchy time. Not yet, Alex. Let's do slow benchy. I'm also not a fan of benchies. I was thinking about doing some Halloween related model. Not sure if there's something nice. If somebody has suggestions, just drop it in chat. This is nice. Nice is going to be an awesome scene action. I hope so. Maybe it explodes or something. Who knows? Shall we do spider pumpkin? It might be too much for the first sprint. Maybe we can do this Halloween pumpkin. I'm not sure if this needs support. Stick the line. The printer supports yes. I don't want something with supports. Let's see if we have a pumpkin. I'm not quite sure why my printables is in check. I think this is a pretty pumpkin. Slicer. So, let's also quickly check the configuration here. Oh yeah, I also set up my the print surface. This was very important to do. You can get this on printables. Somebody made that. Let's quickly check the shape of the bed. I think I set this. Yeah, exactly. What I noticed this week is, oh, you don't see the window. We lost around 10 millimeters in X. So I set the bed now to 225 millimeters in X and 235 in Y. Let's just center that. Let's see. I have no clue what we should do as print speeds and stuff. I don't have any profiles, obviously. Let's just create something random. So layer height is 0.2. First layer, let's do 0.3. Infill, I think 10% is enough. My fill pattern of choice is triangles. Skirt and brim. Let's do 3 loops. Speed. I have no clue. I would just start relatively slow now. We can tune the print speed with the slider later on. Travel, we can go straight to 300. So that's that. Printer settings, let's quickly check the extruder. So the lift, let's just set it. Here's the thing, like what this machine is really good at is Z hops. Because the Z speed is insane. The Z speed is the same speed as X. So it's really fast in that. So let's just use that, actually. Yeah, 0.2 is fine. And then the retraction. It's the Bowden setup. So I would just leave it at 5 millimeters for now. And then let's just see what happens. Yeah, let's just quickly save it here, actually. And here, let's just create a profile we have. So this is 0.4 default, whatever. Let's slice that bad boy. I'm aiming for like 30 minutes, not 3 hours. So let's scale it a bit down. Let's just do 33%. Let's do mini pumpkin. 23 minutes. So 40%. 34 minutes. 36. 25. Okay. I'll take 25. Benchy scale to 100% of the bed size. Well, if we do that, Casted, then we're done tomorrow around this time, I think. Yeah, I think we can hit print. I don't. Oh, let's clean the bed. That's one thing we should do. Let's quickly clean the bed. Because I did not clean this in a very long time. I have IPA, isopropyl alcohol. Let's use way too much. And then I can't wait for my new print sheets to arrive. I always think this can't be healthy to inhale. Okay, I hit print in Crucial Slicer, upload and print. And something is happening. Oh, I just noticed that my frame here is completely off. That's very sad. Let me quickly fix that. Oh, I make it worse instead of better. Here we go. Now everything is back in line. Let's quickly check the stats. So it's heating up both at the same time. That's nice. Oh, you don't see it. It's behind me. 1 second. So (100°) bad for PLA is a bit too much. Yes, I have ABS selected. Okay, upload and print. So, any moment now? Oh, something's happening. The first tiny bits. We could have also purged the filament a bit more. There's white coming out. Now it starts to become blue. Let's see. Should be fine. It looks horribly under-extruded. Let's take a look at that. Oh, I also noticed the music is gone. What happens to the music? Okay, there's something definitely off. Because I hear the extruder click. And this doesn't look like... This doesn't look like what we want. Let's quickly try that purge. Not sure if it's clogged. I have no clue. It seems like from the color that I printed PLA before, so that should be fine. So let's just quickly try to extrude some plastic. Yeah, the extruder is definitely slipping. Let's see, can I? Oh, pull this out. It was kind of, from the shape it was at a nozzle. Let me just quickly try to push through some material manually. Yeah, that doesn't work well. Like, I really have to push. Temperature is still up. Yeah, it's like 220 degrees. Let me just heat it like really hot for a second. I mean, there came white stuff out, so it can't be ABS because all my ABS is black and red. I don't have any other ABS color at the moment. Oh! Now it's suddenly like running out. Something was there at the nozzle tip. Not sure what it quite did. Yeah. Something blocked it. I have no clue what... Because I literally just pulled off this like little thing, but there's nothing in there that looks like something that could block. Okay, but doesn't matter. Let's quickly try again that we can extrude with the extruder. And then give that another shot. Okay, I'm just extruding again. Let's see. We'll need to push a second. I mean, it kind of looks okay. Let's just retry that. Ah, I have like springs everywhere. Let's see. Let me just collect all the trash in one corner again. I'm like full of like strings of PLA. Okay, let's see again. I'm not sure why it's like going down that slowly in the beginning. I mean, it's my macro, so I should know, but yeah, this looks better. It's like almost nozzle cam level. This looks good. But this will be a very tiny pumpkin. I mean, it's too close to the bed, I think, a bit, but details, we can optimize details later. If we get anything out of that, I'm already like super happy. Here you go. Now we can sit back and relax. But it's very slow. Let me. Maybe I forgot how slow Ender sprint, but I think we can up it a bit. What is the estimation here? So it says slice says 23 minutes, and the estimated moment is 36 minutes, and drastically going down because I upped the speed. Yeah, we also have the fan spinning. Yeah, now the fan just kicked in, really. Fan is now 100%. That's really nice. Like, I'm really happy right now. Like, we're working on this now since like 12 weeks. And we finally have something printing. A lot of setbacks, but... what temp I'm printing at? That's my standard profile for the filament. I think it's 220. 220. The bed is 55 and the hotend is 220. But I was like experimenting actually this week with printing 230 on the filament because I had a bit of issues at the V0 at high speeds that the filament, I had extrusion issues. And my thinking, or like my idea was that like if I increase temperature a bit, like it will be more like liquid and I have less extrusion issues at high speed. No conclusion yet, but officially the label says... Where does it say temperature? 200 to 220 degrees. So I'm on the upper there already. Yeah, it's PLA. It's PLA. I didn't like it's open air, and yeah, let's start easy with PLA. I was just wondering. I missed the part. I didn't mention. I first sliced it actually at ABS, which would have been 255 and 100 for the bed. This looks half as shabby, actually. I'm still quite slow. 200%. I don't know, like since I'm used to V0 speeds, everything else is like too slow most likely. We also need to set up input shaper, of course, here. I actually have the sensor module, like since years for like a different project I got that. Always more power. I actually have the sensor module, so we need to kind of like clip it to the bed at some point, and there's a mounting point at the south corner for it. So that's something for, I mean, technically today or next time. That's one thing we still need to do. Another thing we need to do is install a webcam, and this will be like a little bit of like a project because I looked a lot online and I did not find a single webcam mount I'm happy with. So we will create a custom webcam mount, and I'm also experimenting because like the white cables, the CSI cables for the webcam are horrible to route through the printer. So I'm looking for something more flexible. So most likely we'll make our own webcam cable. That's my idea at the moment. So that's the second thing. The third thing we will need to do is lighting. So I want to have a light bar on top to illuminate the print bed. So that's another thing we need to do. I also ordered a Clippy screen. The Clippy screen, no, not Clippy, Nomi screen. Nomi screen is this like screen that basically goes, goes here on the stealth burner. So the screen will be here there will just be a round screen here. But I want to do that once we have multicolor setup ready, because we need to reprint the stealth burner here. Oh yeah, actually, so it's four. It's four. We also need to set up the second extruder, of course. Now I lost track. So yeah, there's plenty of work still on this machine until like that's ready. Layer looks very consistent. Yeah, like hard to see. To be honest, I think it's easier to see on the webcam than for me. It looks good. I mean, like it's also belted Z, so I would hope it's very consistent. I'm not enclosing this printer. The reason is mainly cost. Since a couple of weeks, there's a kit from Seabor, I think, which is like an Enderwire conversion kit, which if I would start over, I would definitely get the kit, because the kit is like 320 euros, which is basically as much as I paid for that, like for all the parts here. But the kit comes with the complete enclosure panels. The only panels I got is the bottom panel, like the bottom panel, and the two deck panels, left and right. And those three panels cost me 70 euros already. So the total conversion cost with both extruders was like 340, and 70 of that was just those three panels. And if I would have ordered all the panels, it would have been like way more. It's just not worth it. Like for ABS parts, I have my V0. This one will mainly be for multicolor prints. That's the only thing. And if I want to do multicolor ABS, I just put a box over it. Yeah, it's working really well so far. Like, I'm really happy. Like, also the extruder, like, chugging along. Like, it's quite fun. Like, when you when it retracts, like, it's crazy how far, like, the distance it rotates. I'm sure if it's like, I think it's 1:4 or 1:5, like the wheel gear ratio. Okay, let me actually relocate the light a tiny bit, because everything here is a little bit dark. This is a very delicate balance. This should be better. I got a new light last week. It's massive. And it's quite a balancing act to not tip it over. Like, moving it is quite difficult. Cardboard enclosure, yeah, so it's technically an enclosure. Like, I also have this like IKEA luck table, where this will sit under IKEA luck table for the next year or so. And what I did when I printed the zero parts, I just put aluminum foil around that luck, like around the table legs of the luck table, and that worked also really, really well. So yeah, if I would really need to print ABS with this, I can, but not really the plan. Ender 3 NG conversion looks pretty interesting as well. Not sure about the price. What is Ender 3 NG? I lost track of all my Enders. They launched so many different Ender variants. I'm completely lost there. But I think it's like Ender 3 NG is like Ender 3 V2 indifferent, something like that. Oh, Ender 3 NG. Yeah. That was like a mod, right? How much is it to convert that? Must be quite a sum as well. I mean, can't be cheaper than that, I guess. Because you then also need extrusions, I assume. You need the same hardware besides the same minerals. I mean, technically you could also do Core XY with re-rollers. It would be quite a thing though. But yeah, like the layers look okay. Also the extrusion looks quite good. It's still a bit slow. It's on printables. Let's quickly check that out. I'll just push the speed to 250%. And then, while it's chugging along, my interest is peaked. Ah, yeah. It looks cool. It looks cool. But yeah, you need a lot of extrusions, right? You need the rods. It has 3 steppers. That's expensive part list. Do you know what the price is roughly? Is there... No, I don't think there's a kit. But do you know what roughly the price is for that? Well, I would assume like 500-600 euros, something like that. But it's like, I mean, like the fun thing of converting the Ender, right? Like for many people, that includes me, this is my first printer. This is not the first printer I used, but the first printer I owned, basically. And it's just cool that I can keep it. Like, it was always like, I never wanted to get like a new printer because, like, you know, it prints, it works. Like, it's technically enough. And now I can keep it, and it's like a very useful machine. Okay, one thing I noticed, the wheel here, I'm not sure if this is in my head or not, but I don't think it's fully like vertical. Right? Like it's a little bit like tilted to this side. It could also be because the belt is not very centered. That makes the impression. But it's something we should check. No, don't know the price. Okay, but yeah, I would guess like 500 at least. That looks like a very expensive project. But I also just noticed we can also just turn on the LEDs here to illuminate the entire thing a bit. LEDs are working. Oh, but now we have a little bit of extrusion issues. Like if you look in there, you can see that. Like there's a bit of extrusion issues in the infill. Like the shell looks okay, but there's a little bit of extrusion issues. Like you see it there, the cross beam basically. It might be just the limit of the extruder. Because like we have quite a like gearing ratio, and the motor is one of the weaker ones. So potentially it's just not strong enough to like spin fast enough. Let's see if that will become an issue. One motor is 10 euros, so I would just like, I mean, motors of that from Creality. Just get 2 new motors that have more torque. It's a shame we don't print that in orange. I don't have any orange PLA. Yeah, the infill is like quite like it draws the infill lines quite fast. So potentially it's just a limitation of the extruder there, which would be a real shame. I mean, it's fixable, but I hope that it can print a bit quicker than that in the end. Check if the extruder motor is too hot. Oh yeah, it's toasty, to say the least. I mean, I can put my finger on it, but it's not cool. Like those here, the AB motors are completely chill. I mean, I'm not sure. I have those heat sinks, and I put this on my USB hub because my USB hub got super hot. But I have a couple of those, so we can use those heat sinks. Let me. I'm pretty sure I can pull this one off. Let me grab. Let me actually see. I think I have another one. Somewhere in my box of chaos. These are all, this is a complete mess. There's one, there should be a second one. Let's see. I also have some tape. I'm not sure, this tape is most likely not really like heat resistant or anything, but good enough for now. This might fall off. I'm just putting double-sided tape on that. Hi there, 3D Printing Lab. You're just in time. Okay, let me just. Not sure if this helps. Most likely it will fall off, but also like the stepper on my extruder of my V0 is really hot. Well, it sticks quite well, and the heatsink gets warm. Maybe it's actually a good idea to have heatsinks on those motors here. I mean, technically I have clearance for heatsinks on all motors. But those they really chill. I mean, there's barely any Z movements. The AB motors really chill. And there are basically two motors like just doing this X movement, which is like super slow. So how's the Y motor doing? No, the Y motor is also like not as hot as the extruder, but it's doing work. What is the time here? So it says 3 minutes left. And we are printing now since 20 minutes. Oh yeah, but the heatsink gets warm, so and it's sticking, so my solution seems to somewhat work. This looks like a successful print. I mean, second attempt, if you count the clogged nozzle, but it's not perfect, but it doesn't look too bad. There's a bit of inconsistencies in the extrusion on the outside, I think, as well. Could also be just because the LEDs are shining directly onto it, Custard. But it is it's glossy for sure. But then the higher temp should help the extruder a bit with pushing the filament. I think one thing we need to do in a macro here is like we need to pull the filament out at the end of a print. But I think once we have multi-material set up in Prusa Slicer, this should take care of that automatically. It's nearing its end. "48 seconds. Let's see if that comes true. Oh, we also have this little like tiny how's it called? Like on top stem? Yeah, little tiny stem. Yeah, but also like I think, did you feel like it got faster when like technically it should have been now double speed from what we had in the beginning? I don't. Let me just like set it back to 100%. I don't feel like it moves slower now. I mean, now it's doing the stem, so maybe we're like a little bit too late. Little tiny stem. Here we are. this is our first print. It looks okay. Like there's some issues with the layers for sure. Like you see here, there's like one ring that's like a little bit like more pronounced. Could be extruder. Could be that. But it's just one ring as far as I can see. Like the rest looks kind of okay. It's just like this one ring going around. Besides this, it looks totally doable for first print. First layer we need to tune for sure. And the overhang is not perfect here. Like on the bottom where it's like a very steep overhang. But overall, hey, it's a first print. Happy Halloween. Well, I call it a success. The filament is okay casted because the user also might be 0. That should be fine, unless it now suddenly started to be inconsistent. But yeah, that's cool. Well, I guess let's start something else. Yeah, now we listed like all the to-dos that we had. So technically what we could do now, we can set up the second extruder and try to do some multi-material magic. That would be, I think, a really cool thing. Because I never, I mean, I did do it like years ago on an Ultimaker. But maybe we can also make a first multi-material print today. That would be really cool. Yeah, I think it would be cool. Like we need to figure out how to set up the second extruder in Clipper, and then configure it in Prussian Slicer. Yeah, cool. Let's do that. We already plugged in the second stepper, right? So that's ready to go. So let me quickly grab a second roll of filament. Then we can like equip that properly. And then I think we can go into the configuration section and make it work. Give me like 30 seconds to grab material. I'm right back. Oh, my macro keyboard stopped working again. Here we go. So we have more PLA. Let's stick with PLA today. We should also then calibrate the E step. I would assume that's very similar to the other side. But maybe let's quickly set it up and then calibrate the E steps first. So let's figure out how it works. Clipper multi extruder. So we have one extruder, and then we have those we don't need because we have This is not what we want, because this is like two separate nozzles, like defines the sensor twice and everything. Let's see, shared nozzle. Single nozzle multi-extruder. This is what we want. So let's go to printer config. And where's our extruder? Here. So we set up extruder 1. And then the important part here is the shared heater extruder. This one we can copy from here. So step pin is this. Deer pin is this, which most likely we also have to invert because the other one is also inverted. And then the enable pin is this one. And then we need to set the TNC driver. And we know PC6 is here. I mean, the other thing that why it could run quite hot is that we have a very high run current here, right? The others have run current 0.5. So let's just put this also to 0.5 for now, the run current for the two extruder steppers. Wait, what did I do now? 0.5, 0.5. So that's in line. I'm not quite sure about the run current, but 0.7 is definitely higher than the other ones. Yeah, then we need a gear ratio of... So those settings we can all copy. Do we have a step distance defined here? I don't think so. So let's remove the step distance, and the nozzle diameter shouldn't matter. And this one we defined now twice. Oh, this one also. Okay, so this, let's see what Clipper says about our config. Clipper seems to be happy. Then let's quickly do a stepper bus for extruder 1. Yep, it's moving. Not sure if you can see that. So that's good. We have a moving extruder. That also means min extrusion temp, or we copied it down. Let's just put it back to 170 here already. We changed that before. Oh, I assume because we now say shared heater extruder that this setting also applies here, but let's just quickly copy that down. Oh, option shared heater is deprecated. Min extruder temp is not valid. Okay, so we don't have to copy that down. But it also now says that shared heater is deprecated. Shared heater, Clipper, deprecated. The swing step to extruder command is deprecated. The set extruder step distance command is deprecated. Extruder shared heater is deprecated. These features will be removed. Replace extruder config sections with extruder stepper config. Okay. Supports for additional stepper synchronized to the movement of an extruder. One may define any number of. Okay, we can try that. So instead of extruder 1, we just have an extruder stepper. Let's call it second, I don't know. And then we just copy those. Let's call this one extruder 1, and then I assume that we also need this TMC section here. Because the step like those, that's not what we see here, right? And I think micro steps is also defined here. Let's also copy that down. See what it says about that. And then extruder needs to be extruder, I guess. And then this extruder 1 section can go. I'll leave it here for now and just comment it out. I also see the gear ratio should be here most likely. Let's see if that works. No. Could not find config section extruder 1 required by TMC driver. Okay, so this one doesn't like that. Let's see, extruder stepper TMC. This is a very long config. Extruder stepper, share stepper. Okay. So we need one extruder stepper, extruder 1 here. Let's see if that works. Accepted it. Let's just stepper bus again. Unknown stepper extruder 1. Is it now extruder stepper? Huh. What happens if I now extrude? Let's quickly remove. Oh well, that was not so smart. Let's quickly remove the golden tube here. I'm quickly cutting this. Oh, amazing. Let me just quickly pull out the filament. Yeah, wait. Let me show you the magic I'm doing here. So let me just basically remove the bone setup completely, more or less. If it wants to be removed. Technically this can stay on actually. let's keep this on. Okay, so let's just see what happens if I now extrude. One of the two should do something. Aha. Well, but that's not really useful. Both are now doing the same thing. Just in reverse, but it's not really like useful for us. So it's really like synchronizing the steppers now. Need to extrude for macro for each stepper? I'm not sure. I would have expected that I can now somehow select between the two extruders. Oh, there's activate extruder command. Missing extruder. Oh yeah, wait. So there's something, activate extruder, missing extruder. So the command exists. Can I search for that? Change extruder, but it doesn't give any information. But the thing is, like, now, like, both are doing the same thing, so that can't be right. That can't be right. Because if I could switch between them, then one, I would have expected this. One does something, but one doesn't. But now they work in tandem, basically. So looking at this, I mean, this is not a setup we have at the moment. But here they now say activate extruder. I mean, let's try that, right? We can do that. For us, this would be extruder 1. Is not valid for extruder. Let's quickly check. How do we call that? Yeah, extruder 1. Extruder is already active. And extruder 1 is not valid. So that's not something we can switch between. Aha. Let's see about. Let's just copy that. But one thing that I already saw is that, like, the second extruder we just added runs the wrong direction. I guess because it's mirrored. So the deer pin here needs to be not inverted. Let me just put this stuff here. So this one is extruder 1. So basically where they have belted extruder, we do extruder 1. Let's see what that does. So now we should have T0 and T1. Hey, ballistic tech. You missed our first print. It's printing. We're currently trying to set up the second extruder. So if I now do T0 and I extrude, Yeah, still both are running. So we still have like motion on both sides. So this one runs, but this one also runs. So that doesn't really do what we want. Oh, but it also says unknown command T0. So that was not very successful. What did I copy there? Yeah, G-code macro T0. So it should know that. Didn't I restart? Maybe I missed a restart. So T0 is active. Let's see what extrude does. Yeah, only one moves. Only this one moves. Let's do T1. And extrude. But this one is still running the wrong direction. Oh no, this is running the right direction, ignore me. Cool, so we can switch between the two. Just for the fun, let's do T1. T0, extrude. Oh nice, I think I joined at 2 hours. I have to go back to and rewatch. Well, you didn't miss too much. Like, we printed that, we set up one extruder. So let's quickly calibrate the second one, and then we can try to figure out how to set up like multi-material in the slicer. Okay, so I'm quite optimistic that the rotation distance we have from the other side magically works on this side. So let's just feed some filament here. Still trying to figure out how to do that best with that. Oh wait, I have the wrong one. No, it doesn't grab it yet. It's a bit tricky to like feed that in here. Not sure why, but there's like something it catches on. Let me cut off the tip, maybe. Maybe we have more success with a fresh straight cut. Nice. But I already had filament through here. See. Yeah, now it's pulling it. Okay. Yeah, now it's through. Okay. Woo. Christ averted. Okay, let's quickly mark our magic 12 centimeters. And then we do M83 and where do I have it? G1 E100 F60. And then we wait. In the meantime, let me find a second of those heat sinks. And now that I one more somewhere in this box. At least that is what I thought. Let's see, fans, springs, but no heatsink. Nope, maybe it's somewhere else. I have at least one more box with tail stuff, so it might also be there. And I guess this one has to live without a heatsink. I could also try to pop this one off, like that I put on my USB hub. See, it's coming closer to 2 centimeters. Oh, it's not. Let's see. Well, there are 2 marks. One is exactly at 2 centimeters and one is a little bit above. So I'm not... Oh no, wait, there's my mark. So it's at 30. Did I put it at 1 centimeter too far? Like, here's the mark I did, and it's exactly at 30. Let's quickly try again. Because it would be like 1 centimeter off would be quite extreme. Okay, let me just try to repeat that. And while we do that, let me quickly grab a spatula and then we pop off this heatsink. I'm back in like 30 seconds. So, trusty printer spatula. I think we can even reuse that glue, to be honest. Let me just... Oh, this might collide with the drag chain. We have to keep an eye on that. Because I can show you, well, we can also rotate it now. This kind of collides here with the drag chain. So this is an important learning, because if we would have the deeper motors, they are 40 millimeters deep. Which is a hair shorter. So deeper motors would have a little bit of clearance here, but still like quite close. Okay. But let's see if we need to replace the extruder motors. Yeah, it's perfectly at 20 millimeters. So I did mark at 13 centimeters instead of 12 centimeters. Then I guess we can pull this out. And feed some real filament. Yeah, I already see, like, this is a bit of a struggle. Here we go. And there's also, like, most likely we should have, like, a little bit of a PTFE tube on the bottom. That's something I still have to add. Cool, but now this should and does pull. So we technically have our 2 filaments loaded. Let's quickly get rid of this little thing here. And we need to see how we configure a Prusa slicer. I would have to keep this as a first print. So. Then let's see, I guess we can just add extruder in general. Extruders is 2. I guess it's all pretty much the same. This all looks fine. But where do we tell it? Rejection when tool is disabled. Let's see. Single extruder multi-material. The printer multiplex filaments into a single hot end. Yes. This is what we need. Custom G-code filament change. Oh yeah, that's a good one. Is this now for us? No, this doesn't look like something we need. Custom G-code. Tool change G-code. Color change G-code. But I guess tool change G-code is the correct one. But there must be some parameter, right? I mean, like, we now have our our T0 and T1. Yes, tool change. I'm pretty sure it's tool change. Let me quickly see if we find like an example for that. Prusa slicer tool change G code. There must be some like parameter or something you can use to get the this one is what I was looking for. Let's see. So we basically put this one here because the T0, T1 is exactly like the macro we set up, right? So what we should do here is we do a retract. I assume. So we do M83. G1. E. Let's just, for now, let's just do 10 centimeters. I'm not sure about the... Let's quickly try that. G1, E minus 100, F 400. So if I do that... Yeah, I think that's okay speed. Maybe we can do 600. Oh, it's already... We completely unloaded it. See? I leave this heatsink out for now because like this will collide with the chain. I don't want to break anything. Okay, so 600 it is. So we retract 100 and then we change the tool and then we load 100. Oh wait, sorry, you don't look at the slicer. So I do M83, I do that, and I do that, and then I do M84 to switch back to absolute positioning, I guess. I know there's something in Clipper to save the G-code state, exactly this. We should create a macro for that most likely. To switch between the tools, like during a print. Here, save G-code state. So we can do save G-code state, name equals tool change, and then after that we can just do restore. And then basically like it will, we can mess around with stuff here. And then afterwards you can just restore like what we had previously. So the positioning and everything will be, we don't have to worry about that. Okay. So we should wrap this into a macro. Let's also do here lights pending, lights printing to turn on and off the lights. Okay, let's just see what this does. I have no experience, so we need a multicolor print. Multicolor print. Let's see. The frog. What's the frog? Yeah, but we don't have that many colors. Because we need 3 colors here. 3 frog. Oh, this looks cool. I kind of like this one. I most like know what you had in mind, but this looks kind of cool. Let's see what this is doing. Oh, that one? Cool. Let's get rid of this pumpkin here. So we have this filament in both extruders, so that's fine. let's just... most likely I have to split by 2 objects. This doesn't look like... Oh, it's missing color, right? That's not complete. And yeah, it looks like a torsion test cassette, but I'm more like interested in the... Wait. I'm more like interested in the swapping action than like a functioning print, to be honest. Here we go. So this one will be 1 and this one will be 2. Yeah, it uses different tools, but it also doesn't generate a purge tower or something. Oh shit, sorry. Sorry. My bad. I tend to forget switching between the different things. I'm very bad at that. So this doesn't look like... I mean, it says the extruder 1 and 2 here, but it doesn't create a purge block. It's most likely something in print settings we need to do, right? Purge. Let's also do the following. Let's just give this a different color. Here we go. Now we see it. Yeah, it's definitely missing like some purge block. Yeah, there's a check for purge block. What I was looking for. Because I only see this one. And line spacing. Oh, here. Wipe. Ah, it's called wipe tower. Here we go. I mean, this is not quite where we need it. So we need to fix that. Position. Let's just position that at 10, 10. With, let's make it a little bit wider. Let's make this 15, 15, so we don't go too close to the edge. And we should also make that frog a little bit smaller. Otherwise we're here like until long time. And we also should have it facing us, right? So let's just make that 30%. Let's do 35 maybe, slice. This will take a little bit longer anyways, and I don't expect this to work at all. 2 hours. But nevertheless, let's try. I don't expect this to work. Multiple extruder step. Oh yeah, I think I found it. So right, we also need to prepare that a bit, right? So let's... Yeah, we should kind of like move... Let me show you what I'm doing. So I would just kind of like move that stuff here. Somewhat here. I have no experience with that whatsoever, but I see that the brim is done in 2 colors. So it will kind of prime both of them. So they're both like basic just on the edge now. And let's just see what happens. Like, I expect it to explode basically. By the way, Ballistic Tech, I hope you're happy now. I changed the homing direction. No longer homing to max, homing now to min. Let's see, the bat needs a second to heat up. $40 out of 55, so we're almost there. And I'm also like curious now the... Yeah, so basically let's see how the first layer goes. If the first layer looks somewhat doable, then I think we already have quite a win at hand. If the color change works at all, like I'm already super happy. I don't expect it to work. Nero did the dual extrusion bed slinger a while back. Wonder if he has conflicts of saved somewhere. Most likely he does. I'm pretty certain that he has exactly that setup, just not as an Enderwire, but as a proper like Switchwire. Because I recall that he had also like a dual extrusion Switchwire with 2 M4 extruders. Here we go. I also need to fix that, like this is way too slow. I just copied all the macros from my V0 actually. Oh, it's using the white one now. But it's, we didn't put it. Okay, so it's pulling out the white one. Okay, 10 centimeters is way too far. Okay, it's also going over the... Okay, let me quickly stop that. So it's going over the clip. I mean, it extruded blue, and it did something. So let's do a quick iteration on that. So firstly, on the custom G code, instead of 10, let's do 5. So it's 50 instead of 100. That should be plenty. Then let's also push the current extruder on the start. Let's leave it out for now. So I changed this one. And then the main thing I want to change is the purge or the wipe power position. So I think X15 is fine, but let's just do 50 for Y. Let's try that again. But let me also just make sure to push the filament. Like we know that it starts with this one, so let's just push this almost in. And let's just try again. Yes, for the Switchwire, that's right. Yeah, I think it's exactly the same setup. But I think it's kind of fun to also figure it out myself. Let me just, if this doesn't work at all, I'll gonna look up some sample configs, because I'm pretty sure it's like more or less a common is like a strong word, but for the afterburner there was a Y block like this. Like for stealth burner I designed this one myself, but for the afterburner there was one pre-made, so I think like a couple of people have to set up. Somebody must have a config. Let me make sure there's no like stuff on the nozzle. Will also be nice to have like a brass brush somewhere where you can like brush off the nozzle. That would be pretty cool. But then like the build volume's already rather small here. It would be quite cool. Like on one side you have a clicky probe like to come in, and on the other side you have a brush to come in, and then you can brush off your nozzle. Oh, it's still like the blue filament is still in the nozzle, right? Ah. Okay, this will be a disaster. Oh, it's okay. It's doing blue first. That's good. Then it should now unload blue. Yes, it's unwinding blue. Or unloading blue. I don't know what it's doing here, but it's like going over the... Okay, I'm not sure if that is... Let's see. We're doing something, but I don't see any white yet, so I don't think this this worked. Is there enough room on the front left of the bed outside the build volume? I'm not quite sure. Like 0, 0 is directly on the corner. I did check that. So I'm not quite sure why or what it's doing here. There must be something from Prusa Slicer. Okay, so the question now would be, let me quickly see, how much stuff does it print there? Yeah, it should be quite quick for the first layer. And then we should see a color change. And I'm curious, because like here it did not do anything white. Oh, so what it's doing there doesn't look really good. That's a different topic. I just want to see like some white, that like the color swap works, then I would be already very happy. Yeah, it doesn't quite stick to the bed what we're doing there. For a nozzle brush, you can... Oh, you mean enough room on front of the bed for a nozzle brush. You can mount it under the side of the bed, but outside of the build volume on left. The problem is that there's no motion like outside of the bed. So basically what you see here, this is the absolute minimum it can do because of the end block here. Okay, now it's like loading white. Let's see. It's doing the white. Well, there's no more blue coming. Which I guess is somewhat. At the moment, there's just no extrusion at all. I mean, potentially we never like push the white one far enough. Okay, let's quickly pause that because that's kind of like pointless. Okay. Let's create a clipper macro that we can use. Because we kind of need to prime that at the print start. Okay, let's see. So maybe let's do the following. Firstly, let me keep the temperature up, so we don't have to wait all the time for that to heat. Then let me just bring that to the front. Okay. Let's just, at the moment, we are active with the white filament. So let's just kind of like extrude a bit. I just want to see it poop out some white. Because now it doesn't move further. Now the question is whether we are, like, if the blue filament is still in. So let's just do G1 minus 10. And then we do T0 to switch to the other tool. And then we do... I just want to see it up here. Let's just make sure that it's moved all the way to the bottom. Hotend is on, so we can, let's just extrude some blue. Ah, it's a nozzle clogged. Okay, I want to see that up here, that we just see that's out. Oh yeah, I think they're somewhat tangled right now, maybe. Because right now nothing's happening on either side. If I'm pulling out. Ah, here we are. So this one is now here, so we see it. Oh, you don't see what I'm doing, but the white one is now out. Maybe it's interesting for you to see this one more than the browser. So let me switch to T0, which is the other side. You said the retract was way too far, right? Yeah, for the 10 centimeter what it was, but maybe I was wrong and it was just like not very deep in and then it was way too far. So what I'm trying to do right now is like I want to see both of them here, and then I want just to see how far do I have to push it in, like how many centimeters to have extrusion, because then we can tune that. So we are at T0, and then let's just pull it out. Here we go. So now both of them are here. So let's do the following. Let's just move this back in 10 millimeter increments. So I'm moving it 10 millimeter forward and we count until we have extrusion. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it wasn't too far. 11, 12, 13, 14. 14 centimeters we need. Let's verify that. So if I do minus 140, then we should see it back up here. Ah, extruder moved too long. So I can only do 120. So we need to change that. So this was 120, extra 20. Perfect. Now it's here somewhere. So this works. So we need to pull 14 centimeters, which also means we need to change the config really quick, that we can actually pull 14 centimeters and it doesn't tell us that it's too long. So let's see. In our extruder section somewhere. Where do we have that? 120. So we just set this one to 150 so we can make the move in one go. Custom, yeah, exactly. There's a setting for 100 and we changed it to 120 when we calibrated the extruder. Yeah, I had to change that for my auto load macro. Yeah, exactly. So let's quickly do that. And then before I forget, I set the temperatures back up again to 220 and 55. Okay, so let's quickly change the slicer macro, or like the change. So here not 50, but 140. And then the thing is, like at the beginning of the print, we also make sure that one is kind of like ready to extrude, right? So I would say we just add to our start G-code. I'm just really hacking that together right now. So this one here. Oh, but this one should be the start G-code anyways, right? Start print. Let's quickly save that here. Because I copied all the macros from my 0.2, let's just copy this back. That explains a lot. Save. And then what I would do here, let's just activate we can do that later elegantly, but I would just basically have the tool change G-code up there. Then we make sure that we just push one. There must be macro or like a variable for the first extruder. Then we activate this one. Because also this seemed a bit random right now, which one we start, right? The first time we print this, it started with white, and the second time it started with blue, if I recall correctly. So remove the retract, so we just move it forward. Let's see if is there. Pusher, slicer, first tool, index, G-code. I mean, we can also, let's just assume it's T0 for now. So let's just say T0 and then do that. Yeah, and see here, there on the bottom. Oh, sorry, I forgot to switch back. Here on the bottom, there's this yellow and the red one. And this is what runs over the clip in the beginning. Not sure if you need to retract it all the way. I don't need to retract it all the way for sure. For now, I just want to see it up here, because then we also see how the tip looks when we reinsert it, because I think we should tune it a bit. Like here you see like a quite long like strain in the front. I know there are ramming settings in Prusa slices to like push it down a bit before you pull it out. So for now, I just want to see them. Does anyone know how I can change this section here? Oh, this is called like here, this like yellow and red section here. Because it's not coming from the start G code. It's not the wipe tower. I mean, for now it's fine. Let's do that. The only problem is I will like do the purge line in the start print macro, and then it will like ram T0, but it should be fine. Let's see what happens. Let me just move this clip here. Out of the way. I don't think the bed will move. I just moved it there. Let's see. It should start any second. Oh, but now we'll also do the prime, like the proper start G code that I have as a macro and clipper. Move exceeds maximum extrusion. Okay, so we have an error. This is something that is in the config. Wait, did it drop the temperatures? Yeah, don't drop the temperatures, please. It's in the extruder section. I had the same with the V0. Clipper maximum extrusion. Some that's just a 1. Max extrude distance. No, max extrude only is something else. The cross section, I think, is what we need. But let me quickly see the error again. Is 1 enough? Yeah, it's 0.849. So let's do firmware restart. Let's put the temperatures back. And then let's just print that frog again. Let's see. Yeah, exactly. Now it's like not like doing anything in the purge line. And now it's pushing the 14 centimeters. Which needs to happen basically before we purge the nozzle. Oh, now it's unloading the 14 centimeters again. like it's unloading again. Cool. And now it's loading it again. There's some efficiencies we can do optimize, but let's see what it's doing. Oh, but now it's pulling the white one completely out. Why is it doing that? Okay, something is not correct because now it's pushing the blue one again. Okay. Let's quickly pause that. I mean, now we have like the biggest blue blob here ever. And this is now, I think, yeah. Let's quickly check the G code actually. Like, what is it doing? So what is it doing? So we say here tool change. And then it's changing to T0. But the problem is it's unloading whatever is there already. Then there's tool change wipe. Then we have another tool change here to T0. So it's changing from T0 to T0. That's what we saw, right? Wait, did I copy this? No, I didn't copy tool change comment. Where's the start G code here? Because I'm missing the start G code here. Maybe it just doesn't include that. Yeah, there's no start G code here. But then we have a tool change. Okay, let's start here. So it's tool change T0, restore, and then we have a T1. So this first tool change is already weird. Then it has just a T1. Is that something we messed up here? No, there's only this one. So if we just say tool change end here. And so it seemingly doesn't include the start G code. So let's remove that. And quickly slice this. Cross-section tries to prevent much filament area from being extruded, relatively small movement. Yeah, exactly. Interferes with purge lines a lot. Yeah. Okay, let's start. So we have tool change start and tool change end. Now we have this random T1 command here. So T0 is basically, it means it pushes the blue one, it pulls the blue one out, then it pushes the blue one in. Then it switches to the white one. Then we have tool change start, and then we switch to T0 again. And after tool change end, we don't have like another T1. Yeah, and then it starts. So what I'm thinking is maybe this one here not working, this if. What if we just quickly make this can we just kind of like show this? T0 and then there's a 1. And then later when we switch to the other one, T0, there's also a 1. Then it has T0. So something doesn't work there with that switching script. Because here we see it's yellow, so it thinks it's doing. It thinks it's doing. Oh, it thinks it's doing white here. This one should be white, right? Because it's the. Let's do the following, just like for our or for my sanity. Extruder 1 is blue. Extruder 2 is white. This should make it easier. So it thinks it's doing white, but we saw here that it's doing blue. So that's something is wrong there already. Tool change start. It says T0 here and 1 here. Then it's doing that. And now we have the tool change. Tool change start. And here's again T0, but this should be T1. No, this should be T0, right? Yeah, T0 is blue. And here, before we have the white one, we have tool change T1. I mean, there's this T1 command here. I mean, this seems to be run before, because it issues like another T command afterwards. So if I completely remove that, and we just look at the G code that it poops out, then we have here the tool change, and then it says T1, and then filament G code. Then we have tool change, and then it has T0. So it activates the tool itself. So what we need to do is basically the pull, what we did. So this one doesn't work. The question is, why is this swapped? Let's see. Tool chain start, we go to T1. Yeah, now it's T1. Tool change, and then we have T1 again, and then T0. Now the question is, do we ever see T0? Like once this is done here, and there's not a tool change. No, there's not a T0. So this just doesn't work. This if doesn't work here. Let's see. Prusa slicer G-code current extruder. List of placeholders. And there's an initial extruder. Okay. Let's see. And we print current extruder, we print underneath, right? In a line. And then we see T0, 0 here. But see in the beginning, T1, 1. Oh yeah, there's a T1, 1. And then we have tool change, T1, 1, and then it's T0. So basically the current doesn't update in time. That's what I would expect. So we have here T1, 1, and then it switches to T0. Wait, we have 1. Then we do 0, right? T0. So I would expect that the next one would be T0. Yeah, T0, and then we have 1. So the problem is that the current extruder in the script doesn't update yet. It's always 1 late. It's always 1 late. Like basically, like after this ran, then the current extruder variable is updated. Let's see, Prusa, slicer, tool change, unload. I wonder if there's not a standard setting. Let me quickly Google this. Prusa slicer, single extruder multi-material. No, I don't think. No, no, that's definitely not what we want. Let's see. Oh, sorry, I forgot to change again. Firmware set to Marlin 2, that's correct. This is something we can change, but shouldn't cause any massive issues for now. Aha, next extruder. That's the problem we have. Next extruder. Because we use current extruder. This is the solution we needed. So instead of current extruder, and we also don't need this weird if here, we just say next extruder. Let's slice that and see magic happen. So we have tool change start, and then we change to T1. T1 being blue. No, white. So it does the thing for T1. I think this is the section. Let's quickly check something. Let's just add that here. Current to next. So we just see it printed like what it's doing. See in here, there's tool change 1 to 1. So what we can do is if current extruder is not next extruder, we can skip this entire thing. Then we should not have this like thing there. Oh no. Is it end if without the underscore? No? Unknown syntax error. Oh god. How was the if? Oh, the if needs to be inside, of course. If current extruder and if. Let's see. Yeah, now it compiles. Okay, so tool change. Yeah, now it completely skips that because it's 1 to 1, so we have nothing here. Okay, cool. That looks better. And then here we have tool change 1 to 0. So we have lights pending, M83, we retract on 1, T0, perfect. So now let's quickly do the following. Ideally, wait, custom cheat code. In the case where we have the same one, let's just skip the retract. But we still do the push. then we can make sure that on the print start, we kind of see both of them here. And then it should work nice. Okay, then I think we now have working G-code. Let's check that the machine is ready. So I just want to make sure that we see the filament in both here. Then it should be like roughly in the correct position. Okay, blue is currently in the hot end. White white is way too much retracted, I remember. Let me just push this through. So we kind of have it here. So I kind of want to have here at the same thing, then it should be fine. Let's see, it's heating up. I'm waiting until it's heated up, and then basically I push out 5 millimeters down and 140 back, and it should end up right where we want it. Oh, that was my headset. So, the temperature should be up. Okay, let me do my little push. It's not pulling it. Not sure if you can. Ah, the retract doesn't work. Not sure why my retract G-code doesn't work. Still pulling it out. Now it should be coming up here. Yeah, barely. Let me pull another 5. Oh, that was 25. I just want them to be kind of like on the same height. Yeah, that counts. Okay, then let's print that again. So now basically, oh no, also the LEDs work. It should basically now home, then it should push in one of them. It should push in the white filament, 144, then does its weird purge thingy here. Then it should do the tool change where it's pulling the white one here again. And then it's doing the blue one, and then it should work. Let's see if we have any success with that. Heating up shouldn't be taking long. No, it's already there. Not sure what it's waiting for. Here we go. Now it's doing the purge line. Yeah, now it's loading. Yeah, no, it's unloading. I mean, it's still printed blue, but should be fine. Yeah, see, there's a bit of blue actually still left. This looks way better already. Oh, there's a big blob now. Cool. Okay, now it's printing the blue part. I wonder why there's not this big blob. But then basically I just need to like extend my start print macro that it doesn't do the white. I mean, it doesn't hurt, but it's kind of pointless. And at the end, we need to pull out the 140 millimeters. That needs to be something in the end, like in a print end macro, I guess. See? And it's not really sticking to the bed that well, but that's a different topic. I'm more interested in the color change. Which should come up any second now. Yes, now it's unloading. Unloading. It's weird that it does it over the print. I would expect it to move out and then do the entire thing. Now it's loading the white one. See, like the. That's like something I would expect to happen here, not over the print, because this will leave blobs and stuff. Let's see if there's anything coming. I mean, it's like feeding the white filament. Doesn't look good. It's doing the right things, it's just not doing it good enough. Let's see if it manages. No. Okay. I mean, almost. Almost. Test cube for dual extruder on printables. Might be more efficient. That is true. Let's quickly check this one. Printables. Test cube for multi dual. Let's use this one. That is a good one. I just need to quickly figure out again how to combine those two together. I always forget that. This one is 1, 2. Oh. Merge? Yeah. Okay. Yeah, that looks better. Okay, so it should start again with the white one. Let's just quickly start directly with that. The white one is still somewhat loaded. The white one is still somewhat loaded. Oh wait, I have to cancel first. Upload and print. Okay, let's see that. But yeah, I expected this like to take quite a while, like until we get this like properly changing colors. But I'm happy that like at least there's something happening that almost looks like color change. It's heating up. That's already a temperature, so it should start any second. Here we go. Okay. So now it should like create the massive white blob because it's like feeding. Where's all the white filament going? Because it was already almost at the front. But it's like, it's pulling it out. Not sure. Like, it's out here. There's some blue fragment there. Now it just makes a clogged impression. Yeah, it doesn't feed filament at the moment. Yeah, it's skipping. It's the extruder is skipping, so something's clogged. I mean, the white one is out. Let's see. I'm trying to push it again with the extruder. Yeah, it's skipping. Maybe the white filament snapped. I mean, possible. Luckily, it's quite easy to get there. We only need to wait for the fan to turn off. Technically, I can just pull it off and the fan will turn off because the connector is there, but I'm a bit too scared with my electronics luck. So let me just kill the machine for a second. Okay, it's off. Okay, let's see. The blue filament snapped. No, it's still... Ah, wait, no. So far, so good. I don't see any snap filament. Do I have some... Yeah, it doesn't go all the way in, I think. Like if I push this as far as it goes, this is how far I get. So this is somewhere here. So there's definitely like clock. Yeah, see? It's above the heat break. So there's something is clogging it. Oh god. Technically we can... Let's just pull the blue one out for now. Technically I could just turn on the printer and push with the Allen wrench. I guess. But considering the time, I'm also kind of thinking if that's not a job for tomorrow. And I just like try to unclog that tomorrow. Yeah. I think that's a tomorrow thing. I call this a success. We have a little pumpkin, which is successful. No success yet with the multicolor. But we have the changing setup, which is great. And I think if it doesn't... That's also the thing, right? Like in the beginning, it pushed the white filament, and we expected to have a massive blob of white filament here, and there was nothing. So it was already clogged at this point. So without the clog, I think we would have had a success here at hand. Yeah, let me just do this tomorrow. I'm also not quite sure what nozzle I have here. It's like I didn't really check that. It should be 0.4, but don't quote me on that. Yeah, so I'll take care of this tomorrow. I will run the same G-code we just had, like just out of curiosity, and see what happens. But besides that, I'm happy now that it prints. So I might try another like single color print, but for the multicolor, I'll just wait for next stream next week. And yeah, yes, that's it. Thanks everyone for tuning in, and see you next week. Have a nice weekend. Bye.